looks like we're working here. Beautiful. Okay, thank you guys for your patience. I really do appreciate that. Sorry, I don't know what's going on this morning with the Santa Fe single sign-on. But hopefully you guys aren't having the same problems I'm having, and folks will trickle in over the next few minutes. Today we're going to continue talking about quadratic functions. Sorry, this is unrelated. These things over here. All right. So far we've looked at the vertex form of a quadratic. We have looked at the standard form of a quadratic, and we've talked a little bit about factoring and taking square roots to solve quadratic equations. Today I want to look a little bit more at solving quadratic equations. In particular, I'm going to go ahead and introduce the quadratic formula. I'll remind you what the discriminant is, and we can talk a little bit about what the discriminant tells us about the graph of the function and solutions to corresponding equations. And I also want to look at some modeling problems, some real world problems. So I'll hold these over here. We've got our screen share on. Use a darker color. This is MAC1105. Section 007. And today is the 27th, 28th, 28th. All right, so today we're going to look at more quadratic stuff. Specifically like homework 8 and maybe a little bit of homework 9 stuff. We're going to look at some modeling or real world problems. Okay, word problems. We're going to look at the quadratic formula. And I'll remind you about the discriminant. Okay. So last time, we talked about factoring using the AC method. We talked about solving quadratic equations by taking square roots. There is another method for solving quadratic equations. So first, before we get into this stuff for today, first, methods for solving quadratic equations. And I want to say that the terminology here is a little bit weird. People can get somewhat confused about what just the language means. So an equation is something with an equal sign, right? A quadratic function is an expression. That's a function of the form f of x equals ax squared plus bx plus c. A quadratic equation is an equation, something with an equal sign that you're trying to solve that involves a quadratic function. So one of these we've seen, and probably the most useful, is factoring. And there's a lot of ways to do this, but the most foolproof way is the AC method, which we went over last time, but I'll use it a few times today also. Another method you can use is square roots. Right, if you can isolate the x squared term, this works fine, as long as there is no x term, as long as it's just an x squared term and a constant term. This will work. You can also solve these things graphically, and we haven't really looked at that yet, but I'll show you an example of this today. It's not really a method. But we'll talk about it. I would say it's not really a method because you can't generally apply it, and even when you can, it's sort of a guesswork thing. And now, you know, if it's guesswork, then it's not really mathematics. But these are our main methods that we have. And the last sort of thing you can do here is use the quadratic formula if you need to. And I trust that most of you know the quadratic formula, but I'll cook it up for you today, and I'll show you a way to always remember it. Some notes we should make by each of these. This square roots method, this only works if the number b is 0, i.e. on equations like x squared, you know, ax squared plus c equals 0. Stuff like this. All right, these are the only times you can do this. You can't do this if there is an x term. It has to just have an x squared and a constant term. Graphically, of course, this only works if you've got the graph. Factoring only works if you can come up with the numbers that you need to factor. The quadratic formula is the one that's kind of always going to work, right? This will never let you down, but it's kind of a pain in the ass. Factoring is the most common method. This is what will work the vast majority of the time. So let's get into it. Let's solve a few more equations. We've done a handful of these, but I think it always helps to look at more. Yeah, so and there are a relatively small number of people here. We do only have 12 people here. I updated the announcement. So you guys are supposed to look at the announcements in Santa Fe, and in Canvas. So I did update this. I suppose I can post a fresh one. I'll just delete one of these after class. Thanks, Mark. Okay, so let's look at a few more equations like these. And this is from homework 8. This is actually homework 8 number 10. And we're working it as an example. So we want to solve. They say solve the equation 5x squared minus 7x equals 6. And they ask you to solve it graphically. This is a little bit awkward. So I'll show you what they mean by solving it graphically, and then I'll show you how I would go about this, because honestly, solving it graphically really isn't a pleasant way to do things. You can think of this as f of x, and this as g of x. And what we want to do is find where does f of x equal g of x. So we can graph those two things as though they're separate functions, and then try to find the intersection points. Now, graphing 5x squared minus 7x is not super easy. There's no obvious way to do that. If I look at f of x equals 5x squared minus 7x, I can factor an x out, and I get x times 5x minus 7. This tells me that the kind of orange-yellow function here is going to have two x-intercepts. One of them is at 0, and the other one coming from this factor is going to be, well, if I set 5x minus 7 equal to 0, I get 5x equals 7, so x is 7/5. This is really not helpful. we can get some idea of what's going on here. 0, 7/5. This is a little bit larger than 1. It's 1 2/5. So, if I mark 1 right here, 2 right here, 1 2/5, 7/5 would be like right here. We can find the vertex for this yellow fellow. The vertex for f of x equals 5x squared minus 7x has x coordinate h, which is always negative b over 2a, which would be 7 over 10. And then k is always calculated by plugging in f of h, which is f of 7/10. It's not a nice number. This is 5 times 7/10 squared minus 7 times 7/10, which is 5 times 49 over 100 minus 49 over 10. Really not nice numbers here. You can cancel this 5 into this 100 and you get a 20 there, so that's 49 over 20 minus 49 over 10. And then here, if you multiply by 2, this is 49 minus 98 over 20, which again isn't super nice. We can double check our arithmetic. So we've got 49, there. 49 minus 98. Hit enter here, it's negative 49 divided by 20. And there's not much we can do with this. If you ask for this back as a fraction, it's just going to give it to you as 49 over 20. So my vertex is like down here. And we can draw the orange function. I think part of the issue with these problems in my math lab is that the numbers are randomly generated. So you're not guaranteed to get something that looks nice, that comes out nice algebraically. But let me describe to you what they mean by solving this graphically. So all that work there was to graph this orange function. If I add in the graph y equals 6, which I'll just pretend is right here. So this is the function g of x equals 6. It's a constant function, so its graph is a horizontal line. And the orange function here, of course, is f of x equals 5x squared minus 7x. The solutions we're looking for, the two numbers we're looking for, are the x values here. These are the numbers we want. And in a perfect world, this graph would be such that you could read those numbers off. You could throw this into your graphing calculator. Your graphing calculator is capable of showing you these things. So if I type in here 5x squared minus 7x for y1, and then I come down to y2 and I type 6, I can graph this. All right, you'll see the picture that we drew here. If we wanted to, we can kind of try to zoom in on this area by playing with our window settings. I could change my window settings to like -5 to 5. I'll keep the scale there at 1. We go -2 to 10, keep the y scale at 1, and this will bring us a little bit closer into the part that we're interested in. And I can use this trace function to walk around along the graph. And if I look over here, it looks like the x value where these two things hit are between whatever this is, negative 0.63 and negative 0.53. And on the other side, it looks like that other solution is between 1.9 and 2.02. Now, we might hope that this is positive 2 and that this is like, I don't know, negative, what are we looking at over here? Negative 6.3. There's no chance for that to be an integer over there. So let me propose another solution method. Right? If the graph was nice enough that you could tell exactly what this x value is and exactly what this x value is, like we were saying over here, then that would be what they mean by solving graphically. But if we want to solve this exactly, we're going to use algebra. So we want to solve this algebraically. And to do that, I would first try to factor. So I would say 5x squared minus 7x equals 6 is equivalent to, remember what we said last time, if you want to factor and set both factors equal to something, you got to have that thing on the right-hand side being 0. So we got to pull the 6 over. So I have 5x squared minus 7x minus 6 equals 0. And from here, I can use the AC method. And this is a good opportunity to outline the AC method. So first, we multiply A and C. In this case, that's 5 times negative 6, which is negative 30. Then we look for two numbers. We got to find two numbers which multiply to this and add up to the middle number b, which in this case is negative 7. So I want to find two numbers that when multiplied give negative 30 and when added up give negative 7. So we have to think about divisors of negative 30. What kind of numbers do we have that multiply to negative 30? Options besides, well, you know, 5 and negative 6. So of course, negative 5 and 6 would also work, but those don't add up to negative 7. What other pairs of numbers do I have that multiply to negative 30?
Three and 10.
3 and 10? Yeah, good. So 30 is definitely 3 and negative 10 multiplied. And if you add those up, you do get negative 7. So these are my two numbers. So we're stoked on these guys. These are good. Once you find these, you rewrite the middle term using those two numbers. So what I mean by that is we're going to come back here and rewrite this as 5x squared minus 10x plus 3x minus 6 equals 0. I can do that because these add up to negative 7. So negative 7x really is the same as negative 10x plus 3x because negative 10 plus 3 is negative 7. And your next step now is to factor by grouping, and this is the last step. The idea is if you've chosen these numbers correctly, then you can come over here, group these terms together, group these terms together, factor out as much as you can, and then what's left over will be a common factor that you can pull out of the whole thing. So from that first group, I can factor out a 5x, right? This is 5x times x. This is 5x times -2. So I will pull out a 5x, and what's left will be x minus 2. From the second group, I can pull out a 3. So I'll have plus 3 times, and again here the leftover bit is x minus 2. And it's all still equal to 0. Now the x minus 2's are common, right? Both of these pieces have a factor of x minus 2 that I can pull out on the right. So I'll have 5x plus 3 times x minus 2. When I pull these out, what's left is 5x plus 3. And this is all still equal to 0. That's your AC method. It's fairly beautiful, and it's not too hard. And we discover that one of our guesses from the graphical solving was correct, right? We guessed that one of those solutions was 2. But there's no way in the world from the graph we could have guessed -3/5. So just like you would in any other setting now, you set both of these factors equal to 0. This is the same as saying 5x equals -3. So x equals -3/5. And over here, I set x minus 2 equal to 0, so x is equal to 2. So you see what I mean when I say that solving graphically really isn't a method, right? It'll let you down a lot. But this AC method, factoring is good. It will take care of 99.9% of problems. There are some problems for which the AC method will not work. And that's when we need the quadratic formula. And I'll tell you how to determine you're in that situation, and then how to handle things with the quadratic formula. Are there any questions on this example we did here?
Yeah, I have a question.
Yeah, Brooke, what's up?
So when you graph or when you solve graphically, is the answer when the intercept when it intercepted, the parabola intercepted through 6, is that the answer, those 2 points?
So the x values here would be the answers. And what we
Okay.
learned is that this x value, this is actually 2.
Yeah.
And this one was -3/5. But there's no way we could have seen that from the graph, either from the graph that I drew by hand or the graph on the graphing calculator. Both of those would have been hard to detect.
Yeah.
But yeah, the idea here is that the solutions to the equation f of x equals g of x are the x values where the graphs touch. That is the concept that they're asking you to understand there. This is a good question. Other questions on this? Okay then. So not leaving you high and dry on any of these things. Yeah, let's talk a little bit more about the discriminant. So I want to remind you about the discriminant, and I'm going to show you something new here. So even if you've got your notes from last time on the discriminant, I'll ask that you think along with me for a minute. Recall that the discriminant of ax squared plus bx plus c is b squared minus 4ac. Right, this piece right here is what we call the discriminant. We can break the solutions to the equation ax squared plus bx plus c equals 0 into 3 cases. Based on the sign I mean like positive or negative, of the discriminant. And we saw this last time, so I'm just ask you to bear with me for a second. If b squared minus 4ac is positive, then the equation ax squared plus bx plus c equals 0 has 2 real solutions. And this corresponds with pictures that look either like this or like this. All right, each one of these x-intercepts on the graph of that function are a solution to the equation that function equals 0. So the parabola might open down, it might open up, but if the discriminant is positive, then it hits the x-axis twice. Leave a little bit of space here, and we're going to come down. If b squared minus 4ac, the discriminant, is equal to 0, then the equation ax squared plus bx plus c equals 0 has 1 real solution. And this may look like this, or this, where the graph of the function just bounces off the x-axis instead of actually crossing over. So your vertex sits right on the x-axis in this case. All right, and then the last possible case is if b squared minus 4ac is less than 0. If it's negative, then the equation ax squared plus bx plus c equals 0. It'll have no real solutions. But it'll have complex solutions. But 2 complex conjugate solutions. I'm going to talk about complex numbers and introduce you to them in a little bit here. But before we do that, I want to do 1 or 2 other little things. So the picture here is just your parabola. If it opens up, it's entirely above the x-axis. Or if it opens down, it's entirely below the x-axis. Something like one of these guys. All right, so these are the possible cases based on the discriminant and the corresponding pictures of the graphs. In each case, the graph here is y equals ax squared plus bx plus c. I asked you to leave a little bit of space under that first item because I want to add a small addendum here. And it's this. Is this guy working? Yeah. Within case 1 here, if b squared minus 4ac is a perfect square, then we can solve by factoring. If it's not, then we need the quadratic formula. Which is the next thing I'm going to show you, the quadratic formula. So I'd encourage you to make a note here. If the discriminant is a perfect square, then you can always factor the corresponding quadratic to solve the equation. But if the discriminant is not a perfect square, then you're going to need the quadratic formula. So this is useful if you're working trying to factor something, but you can't seem to figure it out. If you've been trying to factor, but you just can't find those two numbers that you need to run the AC method, and you've been trying for a while, then you should compute this discriminant. If this discriminant is negative, then you know you don't have two real solutions. You're going to need the quadratic formula anyway. If this discriminant is positive, but not a perfect square, then you know you'll also need the quadratic formula. And what I mean by perfect squares are numbers like 4, 9, 16, 25, numbers whose square roots are whole numbers, numbers that are squares of other integers. Also worth making a note down here. If the discriminant is negative, you need the quadratic. We always need the quadratic formula for these. That's a slight exaggeration. There are some quadratic equations with a negative discriminant that you can solve by taking square roots. But the safe bet there is to use the quadratic formula. That would be my recommendation. So I want to look at some of these, which means we need to see the quadratic formula first. So are there any questions about what's being said here? All right, then let's jump in. So the quadratic formula. What is that thing? This says the solutions to the equation ax squared plus bx plus c equals 0 are always of the form x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. And this is the part where I get to embarrass myself for your edification. If you want to remember this, go find someone you respect deeply, like a man or woman you love, or a family member who you look up to, or a friend whose respect is very meaningful to you. And if you never want to forget the quadratic formula, you stand before this person and sing x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the embarrassment will be so profound that you'll never forget that moment. It's like one of those, you wake up in the middle of the night going, fuck, why did I say that in 7th grade? It's one of those things. So the good news there is that you won't ever forget that shit. The bad news is, of course, you'll be deeply, deeply embarrassed, but it works. So you do need to remember this. This is something that must be remembered. And I promise if you do that, you will remember it. So yeah, there's that. Thank you, Matthew. I have another way of thinking about this, by the way, that is worth showing you. So remember this forever. But also, this is equivalent to x equals negative b over 2a plus and minus the square root of b squared minus 4ac over 2a. Does anybody recognize this piece?
It's the vertex form.
Yeah, that's h. This is h from the vertex. So this says start at the vertex, then walk left or right, that's the plus or minus, some amount, and you'll get to the roots. So you'll get to the x-intercepts. Here's my vertex, h comma k. This h is negative b over 2a. The things that this formula is finding are these 2 points, the x values there. The x-intercepts are x equals negative b over 2a minus the square root of b squared minus 4ac over 2a. Call that maybe x1, and x2 equals negative b over 2a plus the square root of b squared minus 4ac over 2a. So this is x1 comma 0 over here. This is x2 comma 0 over here. The quadratic formula can be thought of geometrically as telling you to start at the x coordinate of the vertex, which is this, and then walk left or right some amount. So this piece right here, all these fucking pens are done. This thing right here is the horizontal distance from the vertex to the x-intercepts. Right, it's this distance. This distance. So the quadratic formula is quite beautiful in this geometric interpretation. You know that these parabolas are symmetric. They have an axis of symmetry. So if you think about it, yeah, of course the roots, the x-intercepts have to be equidistant from this center point because the graph has this symmetry. But most people never really think about the quadratic formula in this way. And I just wanted to take a second to show this to you because I think it's beautiful and I think it will help you remember the significance of the quadratic formula. You can also think about the discriminant here. So notice that the discriminant is the part under the square root. So if the discriminant if this is negative, then you're trying to take a square root of a negative. Then the x-intercept can't be real numbers, because the formula that gives you the x-intercepts involves taking the square root of the discriminant. If this is equal to 0, then you don't have any distance to walk. If the discriminant is 0, the square root of 0 is 0. Your roots are the vertex. So there can only be one root, or x-intercept. You hear me saying that word root, right? Root is a synonym for x-intercept. And if this is positive, then yeah, you've got two roots. But these are the kind of weird things that people usually wonder, what's the connection? So if that distance is actually positive, if the discriminant is positive, then this distance is positive, which means there is actually a distance between the vertex and the roots, which means, yeah, you're going to have two roots, because you can walk left and walk right due to the symmetry. Okay, so I know everybody's seen the quadratic formula before, but I bet you've never seen this sort of detail. So I would like you to take a second, make sure your notes are clear. If there's any bit of this you want to ask about, please ask about it. Then we're going to solve a handful more problems before I let you go. Actually, I'm going to grab some more coffee. While I grab coffee, you guys polish up. Right back. All right. So I want to run through one of these problems that asks you to do a discriminant calculation, and then we'll look a little bit at complex numbers, okay? If you need any more time with this, you might want to take a screenshot. Here's the first part. Here's the second part. Okay. This is number 15 from homework 8. We're going to work it as an example. We'll see if this pen works. It might die on me and I'll have to go back. So it says, consider the equation x squared minus 14x equals negative 49. They want to do a few things. Write in standard form. With a positive, calculate the discriminant. And classify, so b squared minus 4ac, that's the discriminant. and classify the solutions. And then find the solutions. If possible. I'm going to get rid of the if possible part because we do have the quadratic formula now, so we can always find the solution. So for part A, if I want to rewrite this in this form, I just have to add the 49 to both sides. Right. I've got x squared minus 14x equals negative 49. The only difference between that and the form that they're asking me to write it in is that there's not a 0 over here. A is already positive here. A is 1. So I just need to add the 49 over. And that puts me in this form. The discriminant here, b squared minus 4ac, is negative 14 squared minus 4 times 1 times 49. And my arithmetic is not powerful enough to do this without a calculator. I'm not sure what the square of 14 is. So let's go ahead and ask our calculator. Here, clear this all out. So I need to take the square of negative 14. That's 196. And from that, I need to subtract b squared minus 4ac. So I'll go ahead and write my 196 here, and then I'm going to compute the 4ac part, 4 times 49. 4 times 1, we can write it times 49. I recommend you break your calculations down into steps like I am doing. That way, you can be, it's easier to check your work. It's just easier to look back at your shit and know what you're doing. And now it turns out both of these are 196. So 196 minus 196, that's 0. So how many solutions are there? What do they look like? Are they real solutions? Is there 1? Is there 2? Yeah, perfect, Brooke. There's 1, right? If the discriminant is equal to 0, then there's 1 real solution. Since b squared minus 4ac equals 0, there's 1 solution. And it's real. All right, let's find that solution. So I've got x squared minus 14x plus 49 equals 0. I know that there's only 1 solution. I know that it's a real number. And the 0, the discriminant here, 0 is a perfect square. 0 is 0 squared. So I'm expecting that I can factor this. How do I factor this? I break out my AC method. Here, a times c, remember step 1, a times c is 1 times 49, which is 49. I need 2 numbers which multiply to 49 and add up to b here, which is negative 14. So we think about divisors of 49. Divisors come in pairs. 49 is a perfect square. The only way to get 49 out is 7 times 7 or negative 7 times negative 7. And if you take these two, they do add up to negative 14. So my two sort of special numbers, magic numbers, whatever you want to call them, are -7 and -7. So now I factor by grouping. So this is x squared minus 7x minus 7x plus 49 equals 0. I rewrite the middle term and factor by grouping, I should say. I skipped that step. So here I'm rewriting the middle term. And now we're going to factor by grouping. You guys comfy with what I mean by rewriting this middle term? Since we always pick those numbers such that they add up to this middle guy here, -14, I can always use those two numbers to rewrite. Okay, -14x, that's the same as -7x minus 7x. Because these two sum to this, we can always split this up as a combination of those. Now we're ready to factor by grouping. Here's my first group, here's my second group. From the first group, I can pull out an x, and what's left is x minus 7. From the second group, I can pull out a -7, and what's left is x minus 7. Now there is a common factor of x minus 7 in both of these terms, which I can factor out on the right, and what's left is x minus 7 times x minus 7. I write it like this the first few times I do this to try and help you guys see where each one of these terms is coming from. So the underlined expression has been pulled out, and the big gap expression here is just the first term here and the first term here. But really, what is this? This is x minus 7 times x minus 7 equals 0, or x minus 7 squared equals 0. If you want to write it like that, both are valid. In any case, the only solution comes from setting x minus 7 equal to 0, which means x is equal to 7. And as we suspected from our discriminant calculation, we found just one solution, right? Both of those factors give us the same solution, x equals 7. You have a handful of problems like this in homework 8. Some of them you're going to have a positive discriminant, some of them you're going to have a negative discriminant, some of them you're going to have a 0 discriminant. In all of those cases, you now know what to do, and you know what to expect. Okay. So there's two other things I want to do with you guys today. One of them is to work some real world problems, some word problems, and the other one is to introduce complex numbers a little bit. I think the real world problems are challenging in a lot of ways. So I'm going to do that first, and then we're going to come back and look at complex numbers. Before I move away from this problem, are there any questions on this guy? Here's our actual solution. Okay. The next one I'm going to look at here is, let's see, we can do the rocket, we can do the ball. I think people usually complain more about the rocket than the ball. They're pretty much the same thing. Both of these are a little bit tedious, but they all revolve around the same sort of thing. So I'll write it down. This is homework 8, number 27. We're going to work it as an example. Toy rocket is launched at time t equals 0 from the top of a 116-foot tall building. I don't know who the hell gave this kid permission to take his toy rocket to the top of a building and launch it, but for whatever reason, that happened. And its initial velocity is 116, or what was it? No, 181 feet per second. They tell me that the height of the rocket t seconds later is given by the function, we call it s of t, which is a pretty common notation in physics, negative 16t squared plus 181t plus 116. And you may notice that the 116 from the building shows up here as the constant. The 181, which is the initial velocity, shows up here as the linear coefficient. And for those of you with any interest in physics, it is worth pointing out, although it's not necessary for this problem, this term will always be the initial velocity. This term will always be the initial height. Does anybody happen to know where this shit comes from? I know this is a bit of a reach since probably you guys haven't taken much physics yet. Yeah, this is the force due to gravity. Gravity pulls you down towards Earth at 32 feet per second, 32 feet per second squared, meaning the speed at which you're falling is increasing at 32 feet per second every second. This is the force due to gravity. All right, the orange stuff you don't need to solve the problem. They're just interesting facts, and you may find them useful if you ever bump into a problem that asks you to think critically, like giving you this function and asking what's the initial height? Always the constant. What's the initial velocity? Always the linear constant or linear coefficient. Okay. What this problem is actually asking us to do is to determine the time when the rocket reaches the max height. So part A, when does the rocket reach its max height? And what is that height? So what's the highest the rocket ever goes, and how long does it take to get there? Right, those are the two things we want to answer in part A. They want to know for what time interval is the rocket above 373 feet in altitude, meaning height above the ground. And they want to know, when does the thing hit the ground? Other valid questions here would be, what is the relevant domain, right? So for what values of t is this function a reasonable model for the real world situation? We could ask, what is the relevant range, you know? All of those things that we saw back when we were asking about modeling using linear equations, we could ask here as well. So, max height. How do we find the max height? Just for fun, let's try to graph this. before I even start graphing, before I start putting the function in, I'm going to adjust my window settings. The x's are going to be replacing the t's here. And I know I'm not interested in negative time, but just to give me a picture, I'm going to include -5, and we'll go out to like 30 seconds to start. I'll keep the x scale at 1. Y min, again, I'll keep that at -2, even though I know I'm not interested in any negative y values here. I know that my rocket is starting at 116 feet off the ground, and it's going up from there. So my y max of 10 is nowhere near big enough. I'm thinking like 500 is a good place to start. I'll keep the scale and resolution the same. Let's try this window and see what we get. So let me clear out both of these. Okay. So I've got -16. Remember to use this button down here for negative. -16 x squared plus 181x plus 116. Let's look at the graph I get. How should I change my window settings? What changes should I make to the window settings here in order to get a better picture, right? I can't see the whole parabola. I'm missing the vertex, which I know is important to me. And I've also got all this space out here on the x-axis that I'm not really needing, not using. So if I want to get a better picture for my window settings, what should I change? Good, yeah, very good, Logan. So this parabola clearly goes up above the largest y value I can see here. The largest y value I can see here, that's my y max. Where is it there? Y max, which I guessed was 500, but I need to bump that way up. Let's bump that to 1,000. And then the other thing that Logan's suggesting is absolutely right, that I should lower my x max. I went all the way out to 30 seconds there, and most of that wasn't being, or a lot of that wasn't being used. Let me, I was going to move it to 20. All right. Let me change that to 15 and see what we get. Much better, right? Now I have a much clearer picture of what's going on. We can hit our trace button right here and kind of walk this cursor around on the graph. Right over here is my y-intercept, right? When x is equal to 0, I can't quite get it right on, but when x is equal to 0, y should be 116. And as time increases, the rocket goes up until it reaches a maximum height somewhere around here. And then it turns around and it starts falling back to Earth. And at some point it will hit the ground. All right, so here now y is negative, positive 20, negative 20, somewhere between 11 and 12 seconds, this thing hits the ground. So this is a pretty good picture. I'm pretty happy with this picture. So I entered the function here. I hit y equals. That's this top left button. I hit y equals here, and I type in my function, -16x squared. I'll show you how to do this again. So -16, and then this is the button for your variable. It's automatically going to use x. That's fine. -16x, and then this button raised to the power of 2. And then I hit the over button here to get down out of that power, plus 181x plus 116. And then I hit the graph button. If I'm not happy with the picture I get here, I hit the window button. The x min is the smallest x value I'm going to be able to see over here at -5. The x max is the largest x value I'm going to be able to see. That's over here. This is 15 right here. The X scale is how far each tick mark along the x-axis takes me. The y min is the smallest y value that's going to be visible here. It's not, you can't even really see it. It's -2. And then the y max I have set all the way up here at 1,000. So that's the largest y value we can see all the way up here would be 1,000. And then I just hit the graph button and that will generate for me my graph. If I want to walk around along that graph, I hit this trace button right here. It's the button just to the left of graph. And then I can hit the left arrow and the right arrow, and that will kind of march my cursor around along this graph. So if I wanted to guess at the max height, I can kind of try to find this vertex, and it looks like somewhere around 5.6 seconds after launch, I'll reach a max height of somewhere around 627 feet. But if I want to find that exactly, I'm going to have to do some algebra. And the same is true for all these other things. So this picture is just that. It's just helping us get an idea for what's going on. So now if we want to answer these questions for sure, the way we do it is we come in here and we do some algebra. So what feature of that graph tells me the max height? Yeah, the vertex, right? I need the vertex. The y value of the vertex is the max height, and the x value of the vertex is the time it takes to reach that max height. So h comma k. K here is the max height. And h here is the time to reach the max height. So I need to find both of those numbers, and I can't guess at them. So the graph gives me a reasonable guess, but I want to know exactly what are those numbers. And the graph isn't going to give me those exactly. If you want, you can use a better graphing utility like Desmos. I encourage you guys to play around with Desmos. It's pretty dope. Sorry, this is something I was doing for another class. We'll have to play around with these scales here the same sort of way we did there. I can take my x to run from like -2 to 15, and my y's to run from -2 to, let's say, 700. And now I get a nice picture here in Desmos. Desmos is definitely a little more powerful than the TI-84. And you can, again, trace along this, and it'll do a good job. It'll even find this really accurately for you, but it's not going to be perfect. It's still just decimals. So if we want the exact values here, we still have to do some algebra. Desmos is fun. Play with it. Play with it. But the calculator here, the 8384, this is what you're allowed to use on tests. You're not allowed to use Desmos on tests. So you should practice with the 8384, reinforce with Desmos, and then above all else, get comfy doing the algebra by hand. So how do I find the vertex? Well, h is always -b over 2a. So here, what is b? What is a? A is -16, b is 181. So this is -181 over 2 times -16. The negative over negative will be positive. This is 181 over 16 times 2 is 32. I don't know if that can be simplified at all. This is a place where our calculator can help. Oh, sorry. So I can come out of this and ask, okay, can I simplify 181 divided by 32? They'll give you this decimal. And if you want to, you can try to simplify it using the frac function, but no, we're good here. That's all it is. So this is the exact value. And then as a decimal, this is about 5.656. And if I want to find k, I have to plug h in. So here my function is called s, right? Not f. So rather than saying f of h, I'll say s of this. I need to calculate s of 181 over 32, which is negative 16 times 181 over 32 squared plus 181 times 181 over 32 plus 116. And I will let the calculator handle this calculation. Just have to make sure you type it exactly as I've written it here. The parentheses are all important. So this is negative 16 times parentheses 181 divided by 32, close this paren, square it. Then get down out of the power with the over button and hit plus 181 times paren 181 divided by 32, close that paren, and then plus 116. And this is going to give me a decimal. I can ask for the fraction. Gnarly number, but we'll give both. So this is 40,185 divided by 64, or as a decimal, again, I'm going to round, 627.891. I'm rounding to 3 decimal places. If the problem asked us to round somewhere else, we would round somewhere else. I rounded this one too. I should use a shaky equal sign here. Both of these I'm just choosing to round to 3 decimal places, but the problem might ask us to round to 1 decimal place. I think this guy does ask us to round to 1 decimal place in the homework. So that's it. So this is being measured in feet, of course. Your units are important. Do not forget your units. The h is a time. It's being measured in seconds. The altitude k is a height being measured in feet. They told us that in the problem. So the rocket max height is 627.891 feet. And it reaches that height about 5.656 seconds after launch. All right, so to answer the max height portion here, you just got to find the vertex. Any questions on part A? All right. I know that we have gone 3 minutes over time here. I'm going to ask you guys to be patient with me so we can work through the remainder of this problem. I will try to do it at a reasonable pace. If you needed more time to write down here, I'm going to ask that you just take a screenshot. I'll hold here for a few seconds so you can screenshot if you need. And then I'm going to move to part B. I think it's worthwhile to get through this. If you got to go, I understand you got to go. I'll be posting this to YouTube. But let's finish this problem before we go today. Since we're not getting to talk much about complex numbers today, I am going to push homework 9 to next week, homework 9 and quiz 3 to next week, and that's also, we'll finish those up and then we'll review for our test. So I'll talk more about test 1 and complex numbers next Tuesday. To answer part B, they want to know, when is the rocket above above 373 feet? So we can come back to our calculator, and I can add in the line y equals 373. And then you can look at this graph. What I'm looking for is when the height is greater than 373. So I'm trying to find out what part of this parabola is above this line. Looks like it's from somewhere over here about 1.59, all the way to somewhere over here, about 9.68. Finding those two times, think back to the first problem we solved today. It was the same sort of shit, right? We had a horizontal line and a parabola. We needed to find where they intersected. You do that by setting the two things equal to each other. So we need to solve the equation S of t equals 373. S of t, remember, is the function negative 16t squared plus 181t plus 116. So that's what we're setting equal to 373. We'll subtract over the 373, and I'll get negative 16t squared plus 181t plus 116 minus 373. Again, I'll use the calculator here. And we'll get negative 257. Sorry, minus 257 equals 0. Normally I would say, you should try to factor this, right? It's not totally worthless to try and factor this. But odds are it's not going to factor nicely because these are real world numbers. Things generally don't work out nicely with real world numbers. So we'll use the quadratic formula. So here's A, B, and C. So this is negative B, that's negative 181, plus and minus the square root of B squared, which is 181 squared, minus 4 times A, which is negative 16, times C, which is negative 257, all over 2A, which is 2 times negative 16. We can crunch this in the calculator, negative 181. I'll clean it up just a little bit, plus and minus the square root of, let's calculate this discriminant. So that's 181 squared. And you see what I'm doing, right? I'm breaking it down into steps. So I'm just going to calculate the piece under the square root for now, then I'll rewrite it. And that way I've got multiple steps I can go back and look. I'm not trying to do it all at once in the calculator. Minus 4 times A, which was negative 16, times C, which is negative 257. So this is just the piece under the square root. That's 16,313. 16,313 is what goes under the square root. And then downstairs, negative 16 times 2 is negative 32. So here are my two solutions. I have t equals negative 181 minus the square root of 16,303 over negative 32, and t equals negative 181 plus the square root of 16,313 all over negative 32. I want to point out that you cannot cancel these negatives. This is not a common factor. You can't factor a negative out of here because you've got a plus and minus here. So don't try to cancel negatives like that. Just handle them as they are. These will be the two times that we need to solve part B. These will be the two times when the rocket is exactly 373 feet off the ground. And we know from the graph that in between these two times, the rocket is above 373 feet. So let's crunch these out now. I have my numerator, I'll just calculate on its own, negative 181 minus second here for the square root of 16,303, 16,313, sorry. That's this. And then I'm going to divide that by negative 32. That gives me 9.64757 seconds. So I'll write this down. I've been rounding to 3 decimal places. So it would be 9.648. And the other fellow, I will calculate similarly. I'll do my numerator first, negative 181 plus the square root of 16,313. Enter. And then divide this by negative 32. And I get 1.6649. So that's 1.665 if I round to 3 decimal places. So these are my 2 times. Between these 2 times, look back at your graph. Between these 2 times, here's the 9.6. And here is the 1.66, right? Between those two, the rocket is up here, above 373. So the interval of time values, so the rocket is above 373 feet. On the time interval, remember what an interval is, it's just a set of t values or a set of x values. On the time interval, it's going to be an open interval because we want it to be strictly above. Again, I'll round to 3 decimal places. The open interval from 1.665 seconds to 9.648 seconds. That's our answer for part B. And then finally, to find when the rocket hits the ground. So again, I'll hold here if you want a screen cap. What we did is we set the height equation equal to 373 feet, pulled everything to one side, and then solved using the quadratic formula. From our graph, we know that between these 2 t values, between 1.6 seconds and 9.6 seconds, this rocket is above that height. So from 1.6 to 9.6, the rocket is above that height. This is our time interval. We don't include the endpoints because at those endpoints, the rocket is exactly at 373 feet, not necessarily above. It's a small fiddly thing. Okay, the last part here, part C, when does the rocket hit the ground? We need to solve the equation S of t equals 0, right? S of t is the height. So the rocket hits the ground when its height is 0. That means we need negative 16 t squared plus 181 t plus 116 to be equal to 0. This is going to be another quadratic formula thing. Unfortunately, I have another class that starts in, an office hour that starts right at 11, so we might have to cut this a little bit short. But this would be, again, a quadratic formula thing. So we'd have negative 181 plus and minus the square root of 181 squared minus 4 times negative 16 times 116 all over 2 times negative 16. And again, here I would just break this down into pieces. So let's compute the discriminant first, right? This way you don't make mistakes and you can check your work. The discriminant here is 181 squared minus 4 times, right? Oh, shit, didn't get out of that. Squared, sorry, over to get down out of the power, minus 4 times negative 16 times C, which is 116. So here's my discriminant, 40,185. So this is negative 181 plus and minus the square root of 40185 all over the downstairs here, which is negative 32. And again, I'm going to have two solutions. Negative 181 minus that square root 40185 over negative 32. And this guy I'll calculate. And t equals negative 181 plus this square root all over negative 32. And I'll plug this into the calculator as well. So for that first guy, I'll take negative 181, subtract from it the square root of 40,185. There's my numerator. And now I need to divide this by negative 32. Hitting enter in between is a really good idea because it helps you with your parentheses. You don't have to enter as many parentheses and it lets you check one step at a time. So again, I really recommend you do the calculations as I've done them here. I'm getting 11.921 seconds. Again, rounding at that third decimal place, the 0 comes up because the 6 is bigger than a 5. The other calculation here would be negative 181 plus the square root of 40,185. Here's my numerator, which I will then divide by negative 32, giving me negative 0.608. And if you look at the graph, you can tell which one of these is the solution we want. Let me get rid of this other guy down here. We don't need him anymore. If you look at the graph, one of these solutions is negative, one of them is positive. The negative solution over here has nothing to do with this problem. The rocket launched at time t equals 0. This is the part of the graph that has to do with the rocket's flight. The stuff over here has nothing to do with the rocket's flight. So it's this one that I want. This one is my answer for when the rocket hit the ground. And again, it's a time measured in seconds. Alrighty, I appreciate you guys who stuck around here. I'm going to go ahead and end the lecture here. Next Tuesday, we're going to talk about complex numbers and homework 9. I'll keep quiz 3 open. I'll keep homework 9 open, but everything up through homework 8 is going to be due on next Tuesday. Also next Tuesday, we're going to talk about test 1. We're getting very, very close to test 1. So I will probably, I will schedule test 1 next Tuesday. I don't think it's fair to have the test next Thursday. You deserve a little bit more time to prep. So next Tuesday, I will set the test date. It will probably be the Tuesday after next. But we'll talk more about that next week. Please work hard on getting caught up with all the homework, anything you haven't done up through homework 8. Homework 9 and quiz 3 will be open until next week, but homework 8 is going to be due at the start of class on Tuesday. So please make sure you get all of that done. If you have any burning questions for me, come to me in my office hour. It's starting now. Otherwise, I'll see you guys next week. Okay, take care of yourself.